Welcome back to Explicit Academy. In this video we are going to solve these two differential equations, and after this video our next video will be on integrating factors. So quickly, this is just an exact differential equation, but we have to check if it is exact first of all. So let's check if it is exact. So let's take this to the standard form. If I take this one here, I'll have y plus 2x sine 2y, then I'll have dy, then I'll have dx is equals to cos 2y plus 3x squared dx. So if I take this dy to this side, I'm going to have cos 2y plus 3x squared dx, then minus y plus 2x sine 2y dy equals 0. So this is the standard form, and we said the standard form is f dx plus g dy equals 0. So our f is this and our g is this, and our f is also dz over dx, our g is also dz over dy. So these are the two things. So, and we also said for this equation to be exact, our df over dy must be equal to dg over dx, dg over dx. So let's test this if this is true. So I'll be differentiating this function. Since there's dx, I'll be differentiating it with respect to y. When I differentiate it with respect to y, df over dy is equal to, when I differentiate this with respect to y, I'm going to have minus 2, since this is 2y, minus 2 sine 2y, because when I differentiate cos, I'll have minus sine. So I'll have minus 2 sine 2y. But for this other part, remember that this is a constant. Since we are differentiating with respect to y, I'll take this as a constant, so it's 0. Then when I differentiate g with respect to x, now this g is minus everything here, but let me work with this part first before I put the minus. Now when I differentiate y with respect to x, y is just a constant, so it's 0. When I differentiate 2x sine 2y with respect to y, this sine 2y becomes a constant, so I'll have 2 times this, because when I have 2ax, I differentiate with respect to y, I'll have 2a. What's the a? The a is sine 2y. So if I differentiate this with respect to x, I'm going to have 2 sine 2y. But don't forget that there's a minus sign here, so I'll put that minus. Now because our dy, df over dy is the same thing as dg over dx, we say this is an exact first order differential equation. Now quickly, now we can now solve the differential equation since we know that it is exact. Now remember that our dz over dx is this. Our dz over dx is this. So let me quickly do dz over dx is cos 2y plus 3x squared. So our dz is equals to cos 2y plus 3x squared dx. So I will integrate both sides. When I integrate dz, I'm going to have z is equal to, now what is our cos? If I integrate cos 2y, this is a function of y and we are integrating it with respect to x. Suppose we have a as a constant and want to integrate it with respect to x, we are going to have ax. What is this? Our a, cos 2y. So I'm going to have x cos 2y since I'm integrating with respect to x, plus 3x squared over 3, which is the same thing as plus 3x cubed plus s cubed. Then since when we z is a function of x and y, and when we differentiated with respect to x, there's a constant y that we took as a, there's a function of y that we took as a constant, so we'll add it back. Our constant becomes a function of y. Now remember that our dz over dy, we have worked with this part, is this. So our dz over dy is minus y, if I open the bracket, minus 2x sine 2y. Now if I differentiate this with respect to y, we'll have this. So when I differentiate this with respect to y, I'm differentiating with respect to y, so x is a constant here. When I differentiate cos, I will have minus first, and I will have sine. Now remember that x is just a constant. Let's say we have a sine 2y and we are differentiating with respect to y. I'm going to have a sine 2y. This is what I'm going to have. So I'm going to put this back. This is the a. So since I differentiate this with respect to y, I will have this 2 here times this x. Then cos, if you differentiate, you have this sine 2y. Now this is a constant. If I differentiate it with respect to y is 0, then I'll have the first derivative of this function, phi prime. Now these two things are the same, so when I take this to this side, I will have minus 2x sine 2y plus 2x sine 2y. That becomes 0, so I can just take this out. So minus y is phi prime of y. Now when I integrate both sides as usual, our phi becomes integral of this is minus y squared over 2. Now since we have gotten our function of y, we'll impute it here back plus a certain constant a. So we have z is equals to x cos 2y plus x cubed plus this function of y, which is this, minus y squared over 2 plus a. Remember we said our dz is 0, meaning that our z is always a constant. So a constant minus a constant will give you a constant. So let's take everything to be a constant c. So this becomes the solution to this differential equation. Now let's quickly do question 2. Question 2, we also have to be very careful so as not to make mistake. Now it's already written in the standard form. Remember we said f dx plus g dy is our standard form. Now the dx is here, so it means that our f, remember our f is dz over dx, and our g is dz over dy. So first of all, let's check if df over dy, since there is dx here, if this is equals to dg over dx. So let's check. What is our f? Our f is just this divided by this. I'm going to have y over x. Then this divided by this, I'm going to have x over y. Then plus 1 over x. Now if I do this with respect to y, if I differentiate this with respect to y, I'm going to have 1 over x minus, this is x raised to power x times y raised to power minus 1. So this times this, I will have plus x over y square. Then if I differentiate this with respect to y, this is just a constant, so that's 0. Then our g is this, so let me differentiate dg over dx. Our dg over dx, this y square is a constant, so I'll have 2 times everything here. 2 cancel out 2, I'll be left with x over y square, which is this. Then when I differentiate ln x, I'll have 1 over x. So our dg over dx is the same thing as df over dy. So this equation is an exact first order differential equation. So we have established that fact. Let's now solve the differential equation. Now recall that our dz over dx is our f, and this is our f. Our f is this over this, this over this, this over this, which is just y square over this. That's y over x. Then x square over this, that's minus x over y plus 1 over x. Now this is our dz over dx. If I take this dx to this side, I will have dz is equals to y over x minus x over y plus 1 over x dx. So we have gotten this part. Now if I integrate both sides, our z becomes, I'm integrating with respect to x, so this y is a constant. When I integrate 1 over x, I'm going to have ln x. So this is just y ln x. Then for this part, I'm integrating with respect to x. So this over y is a constant. I'm going to have minus x squared over 2y. Now when I'm integrating 1 over x with respect to x, I'll still have another ln x. So if I take common terms, plus a function of y, since we integrated with respect to x, our constant of integration is a function of y. So our z becomes, this ln x is common, so I have y plus 1 ln x minus x squared over 2y plus a function of y. I took ln x out from these two. What's left here is y, what's left here is 1. So remember that our dz over dy is g. So our dz over dy is g. And what is that g? Our g is x squared over 2y squared plus ln x. So this is our g. Now let me differentiate this with respect to y. With respect to y, this is a constant. This is just a constant. So I'm going to have y differentiate this, I'm going to have 1 ln x. So I'll just have ln x. Differentiate this, that's 0. Taking this as product rule if you like. Then if I'm differentiating this with respect to y, this is the same thing as saying minus x over 2, then y raised to the power minus 1. So if I differentiate this with respect to y, this minus 1 comes here. I'm going to have plus x squared y minus 2 all over 2. Then plus 5 prime of y. So when I take this thing down, I'll have x squared over 2y squared plus ln x is equals to ln x plus x squared over 2y squared plus 5 prime of y. Now this thing is the same thing as this, so they can cancel out. That means if I take this to this part, it becomes 0. This is the same thing as this, so our 5 prime of y is 0. When I integrate 0, our 5 prime is a constant a. So this means that this 5 prime is a constant. So let me quickly take everything here. Our 5 prime is a constant, so let me change it to z is equals to y plus 1 ln x minus x squared over 2y plus a certain constant. Recall that we said this z is a constant because our dz is 0. So constant minus constant is also a constant. We're left with y plus 1 ln x minus x squared over 2y equals to c. So this becomes the solution to our first order differential equation. So that will be all for this video. In our next class, we'll be talking about integrating factors, functions of which we find in this form but are not exact. How do we make them exact? So in our next video, we'll talk about integrating factor. So that will be all for this video. Please do not forget, like, subscribe, share this video. Thanks for watching.
Learning online haven't been more fun. Exquisite Online Tutorials is a household name when it comes to academic excellence in online tutoring of 100-level students to 100-level students and college entrance examination candidates. With the power of artificial intelligence and human studies, Exquisite Online Tutorials have been able to interact with the intelligence of students worldwide, making the good ones better and even the better ones best. Just like Science Bob, Exquisite Tutorials has a great faculty of erudite tutors that inject knowledge, whether science or business management, to the cerebrum of her students. QTME lectures and other college entrance examination lectures are going on as well. Do you still need a physical tutor? No. Exquisite Tutorials got you. Please subscribe to our YouTube channel and follow us on Twitter and Facebook.